Hello and welcome to another CS200 mini lecture. Today we'll talk about collections, chapter 16. In specific, we'll go over chapter 16.1 through 16.6. In this mini lecture, I will cover the material in the Zybook, and I'll have another supplemental lecture with some more examples. So let's get started. Knowledge of collections is important for any Java programmer. There's many times where you'll read in information and you'll want to have it in some kind of order that you want to specify, whether it be in a queue or whether it be in a set or a hash map. You want to have it so that you can access independent rows of information independently. And we want to do some kind of enhancements to it. This is a very common operation in Java. So what we'll learn here in this chapter is important. So the first topic they have is called an enhanced for loop. We saw this at the end of chapter 15, and the for loop has a slightly different format. And the format looks like this. So we have for string player name colon team roster. So what we have is a string is an iterator. It goes through all the items in the team roster. In this case, we declare it as an array list. And what we want to do is we want to iterate through each player name or each item in that array list, which is declared as a string. This is nice because it makes it much more efficient for us to look through and see what's going on once we're familiar with this shortcut. However, there's some limitations to what we can do. Like in a normal for loop, we can decrement rows. So we can put as the third element in that conditional expression in the for loop, we can put like I minus minus. Whereas this goes from the first element to the last element in consecutive order. The nice thing is, not only does it look easy to follow, but it also keeps us from going outside the boundaries of team roster. In this case, we have 3 elements in team roster, and it will only iterate 3 times. So here's an example showing how the same for loop, which is on the left, would be enhanced with the enhanced for loop, which is on the right. If you look at it, the most striking difference is at the top where you have to declare different variables. And so the one on the right makes it a lot easier to understand, and also it's a lot more succinct, but it does the same exact. So you've been exposed to a couple of different types of lists, array lists, and briefly we talked about linked lists when we talked about memory management. So the list interface is part of the Java's collection framework, and this defines a collection of ordered elements or a sequence. And the only reason why we call it a list is because it looks like it's a bunch of items, but there is some kind of order to it. So let's take a look at this here. So we declare it as a linked list instead of an array list of type string. And notice the definition has the angle brackets. And then we have the name of our linked list equals new linked list string. Okay. And then we add the 3. And what it does is using the add, which is built into the collections, is we're able to add a row to the end of the linked list. So we can do it by only specifying what we want to add, and it automatically adds it to the end. But we also have the option of specifying where we want to add it. So in this case, we can just add it to index 1. Remember, indexes start with 0. So it takes whatever's in index 1 and pushes it down and adds what we want to add, in this case green, in the position 1. So this allows us the flexibility of not only starting with the beginning and end, but we have some ability to control what happens in the middle. So we also have the ability to get elements. This means like a retrieval, which we can allow to print to the screen. And what we do is it finds the element 2, and by doing a print line, we're able to print it to the screen. We can also do a set operation, which is basically like an update. So we specify the position, and then we also specify the name that we want to change it to. In this case, we also print it out. We can also delete, which this operation shows us. So we have a list of 3 elements, and we want to get the item that's in the first position, and then we want to remove it. So what we do is we find that position, and then what it does is connects the arrow from the previous one to the one that it connected to. And then we also do something where we print out the element that it points to now. And this is just one way of confirming that it actually did delete it. Here are some common linked list methods. The get we just saw. The set is more like an update. And keep in mind, it does require an index. Unlike the add, which can or cannot take an index depending on what you want to do. Add just adds it to the end. And add with an index and the element adds it to whatever position you specify in. So all the other elements get pushed down when that happens. So their index for the ones that are greater than this index that you provide are pushed down and incremented. Size gives us the number of elements in the list, which is good for iteration, right? Because it gives you a bound. And it also allows you to check values, right? So if the size is 0, you know it's a null list. Remove, you can do it by index, or you can do it by looking up the actual element. So it removes the first occurrence of that element. I suggest you look at the examples over to the side to get more familiar with these. Let's take a look at one that iterates through a long list of statements. And if we wanted to, this might be how we would write code. But what we're going to see here in a minute is a much more efficient way to do this. So we declare our linked list. We declare a string called author name, and we also declare a iterator called I. So we add the 3 to the linked list, and what we do the first time through is we add it to author name, and then we print it out. Then we increment using our for loop to the next value. Then we go back, and you can see how inefficient this is because there's a lot of movement of not only the pointer in the author's list, but also we have to keep track of the author name before we print it out. So there's something called a list iterator. So this is an object, you can think of it like as a pointer. So what it does is it points to the location in the list, and it provides methods that we can use to find the next position. So just like the code we saw here, we're going to do the same operation. So let's take a look here. So again, we declare our list, and we also declare an author name. Then we consider this list iterator instead of that index I. We add our values, and then we say list iterator equals the name of our linked list dot list iterator. So that's specifying that it's going to point to the beginning of the author list. So now we use a while statement, and basically we're just checking to see if it's got a next value. So as long as there's another value in our list, and right now we have 3 because our list iterator is the beginning, what's going to happen is it's going to output the values, and then just what it does is it checks the next value and then outputs it. So this makes a much more efficient way to program, and also it's a little bit easier to keep track of. The only bad side to this is it's going to require you to learn some new programming. So list iterator is something that we declare that just works as a pointer to the actual element in our array list. So what happens is the set method can replace the prior element that was accessed by the iterator. So let's take a look. So while it has a next value, we put this in, and then we convert it to uppercase just to see the difference, and we replace it. So this is a nice way to capitalize the elements or change them inside of the author list linked list. So again, we're using the set, which actually is the one that changes it. It's this line here. And then once we're done, we're going to print them out, which is what we saw earlier. And because we start at the beginning, we're going to go through and print them out in order. This did this fast, but that's one way in which we can print them out. So just like with the array list, we saw some methods that we could use. Let's take a look at some of these with list iterator. So we have the next, which just moves it down to the next element. So what it does is it returns the current one and moves it down to the after that. So if I'm on position 1 and I do next, it's going to return 2 and then move the list iterator to 2 to get ready for the next one. Next index returns the index of the next element. So that allows you to reposition your iterator. Previous allows you to go back, which is nice. Previous index gives us the index of the previous element, whereas next and previous actually gave us the items. This previous index gives us the index of the previous element. So has next and has previous allow us to see whether we're at the end or beginning of the list. And add, notice we don't have the ability to add inside the index. We just have add new element. So it adds it to wherever the current iterator is. So if it's between 2 and 3, it's going to put it there and move 3 on downwards. Remove takes the element that's returned by the last call to next or previous, depending on what you did. So however you got to that position is going to remove the element that it positions to. So wherever that iterator is pointing to, it's going to remove that element, much like we would expect. And set, just like we saw in the example, returns, it changes the value of a particular element. Here's a challenge activity that I encourage you to do. It's a very simple one. It's got a couple of adding, and then we have a set and a remove. And just by going through it, it will tell if you understand how these linked lists work. Okay, let's move on to hash maps in section 16.3. A map is an interface within the same Java collection framework that defines a collection and it associates or maps keys to values. My background is information retrieval, so key value pairs are used frequently. If you follow languages like Hadoop or MapReduce based languages, you'll see that they use key value pairs. So a lot of the searches in Bing and Google, they use key value pairs. So the key might be some kind of unique value, and then the value is actually what's stored. So it might be an index, for example, or a reverse index, lots of different things. But let's see how this is used in an example in Java. So what happens is we declare a hash. So the hash map is declared as a string and integer. So we have to declare both the key and the value. So in this case, the key is going to be the first value, which is the string, and the integer is going to be the value we want to obtain information about. Now, this is different than what we normally see, because normally the integer would be used as the key, and the string would be the value we want returned. But in this case, it's going to be the opposite. So what we have is we have these values stored. Notice so it's California, Arizona, and Massachusetts. And then the population from census.gov for a specific year, 2013. So what we're going to do is print out a line, and then we're going to get Arizona. And notice how it is able to use that key to retrieve the value. So what we did is we printed out the population based on that Arizona value. Now, what this means is we have to be very specific about what we declare as our keys. We have a lot of duplicate values that can be troublesome. Let's take a look at this example, which does pretty much the same thing. So we'll go through the first part pretty quickly. And we see that the population of Arizona in 2013 is, and then because we've changed the value by using a put of Arizona, what happens is it changes the value and then we print it out again. So by doing a put, we update not the key, but the value. And this allows us to print it out again with a different year, and we get a different value, much like we would expect. So the contains key is used to check if we actually have the specified key. Remember, we have key value pairs. So in that previous example, Arizona, Massachusetts, and California were our keys, and the value was the population. So we want to see if that key actually exists. So what we do is we use a hash map to associate a distance with a runner's race time in this example. If the distance doesn't exist, the program prints null. If it does exist, then we're going to print the value. Let's take a look here. So what we get is enter a race distance in kilometers, 0 to exit, and then we put 5, and the best for 5 km race is 23.14. So if we look here, what happens is we initially declared a hash map, we're scanning because we're going to get user input, and we have user distance kilometer, which is going to take the value that we have the user type in. We put in 5, 10, and 15 as our keys and the corresponding values. So here we have an integer and a double as opposed to a string and an integer like we had in our last example. So we prompt the user, get the value input, and scroll down over here. And while it's not equal to 0, because that's our value that tells us to exit, the best time for the value, in this case we type 5, is, and then we use that get using user distance km as the key, and what that's going to do is return the value, right? So the get returns the value associated with that key. So we keep going until we type 0, and so our output's going to look like this. So what are the common hash map methods? We have a couple of them. So put associates the key and the value. So if it doesn't exist, it just puts it in there. And remember, this is not so much ordered, it's just making sure it exists or not. So unlike linked lists and array lists, where we have some kind of way of checking values in some kind of series or order, here we're just checking to see if it exists or not. So put just adds it to the map, actually, and it associates the key and the value in our collection. Put if absent, so what this does is it doesn't specify a new value. So put if absent, only if the key doesn't exist are you going to add it, whereas put either adds or updates the previous key value pair. So we have get, which returns the value, contains key, just does a true false, and then contains value. So we have a way to check the key and a way to check the value. We can remove by specifying the key. We can clear, which moves everything out. We can set a key, so we can return a set containing all keys within a map. So if we look over here on this example, we can assume that the key value pair is Tom 14, John 86, and Mary 13. So Tom, John, and Mary would be our keys. 14, 86, and 13 would be our values. So if we do keys equals the name of our map dot key set, we're going to get the list of all the keys that exist. We can do the same thing by specifying values instead of key set. So what that's going to do is return all the values. So here is a challenge activity that I encourage you to work through. This will help you to understand how these hash maps work. So that was a hash map. And the reason why it's called a hash map is because you have mapped a key to a value. And we're able to access all the values using a key. So a set is just a collection of unique elements. Think about it this way. Is a set a key, or is a key a set? Let's take a look at this. We can use the add, removes, and contains method to add an item, remove an item, or check if an item exists. So going through this example, so what happens is we have a book collection. This is a hash set of type string. So we declare a new hash set. We add a value called Tale of Two Cities, and we also add Lord of the Rings. So we want to see if the value contains a Tale of Two Cities. And what we're going to do is we're going to print that out if it actually does contain Tale of Two Cities. The first part is what we print. The second part is the actual operation to check to see if that value exists. So now we're going to remove Lord of the Rings, and then we're going to check and see if it exists. And it says false because it doesn't. So you can see here that it returns a true false value. So that's why it's a Boolean. So let's see what happens with the add and remove. Specify the failure or success of adding or removing values. So first we populate our books. We have these three. And we add this value here. And we check to see if we could add it again. And we have false. Okay, now we do the remove. The Hobbit doesn't exist. So we would say that we have a false value here. And this would tell us whether our operations were successful. Here is another activity here we can run. Okay, so what we're doing is we're entering a number between 1 and 10. If we specify 0, that's our way to exit. So what we're going to do is we're going to have them guess the numbers. So we import hash set, and we also import scanner because we're going to prompt the user. So we have a public class called guess the numbers. And in this class, we have our main. First thing we're going to do is we're going to prompt and the user to guess the number. And then we have numbers to guess, 3, 5, 1. So we have them guess, and we check the guess. So if the guess is one of the numbers that we've added, we're going to return true, and then we're going to remove that item. We have them trying to guess as many numbers as they can. The numbers they're supposed to guess are 3, 5, and 1. And here's the user input, 1, 2, 5, 3. We have them, they guess a number that doesn't exist in the list, then 2 more that do. And then if they get it so that all of them have been entered, what we do is we tell them that they've won. Okay. So they have to guess all the numbers on the list. If they don't do it, we print a nasty message to them saying quitters. So what are these hash set methods that we can count on? We want to be able to add something to our hash set. We want to be able to remove something. So if it doesn't exist, it adds it and returns a value of true. So it's going to return a Boolean. If it already exists, we return false. So the remove, if it exists, we remove it and return true. If it doesn't exist, we return false. So contains returns true if it actually exists in our hash. And size returns the elements in the hash set. So here's a challenge activity that I encourage you to work through. And let's go on to queues. So queues is another element inside the Java collection framework where we have a collection of ordered elements that support insertion at the tail and retrieval from the head. So it's first in, first out. We can do an add and a remove. The add goes to the tail, so we don't specify a position. You can think about it as a tube. So you're pushing in something this side and it's coming out the other end. The remove removes it and returns the element to the head of the queue. We can only remove from the front and add to the rear. So let's go through this example. So we declare a queue of strings. So we have a list. This looks like a seating at a restaurant, seating list. And so we have 3 different elements that we add. And because it's one that only allows us to take from the head, think of about a conveyor belt or some series in which you can, the order you push them in is the order you're going to retrieve them on the other end. Think of like a pizza oven. So the common queue methods are add and remove, and there's pull, which returns the element at the head if it's not empty. Otherwise, it returns null. So how that would be used is if we have the queue is down and we do a pull, it would return the value that's there. So it's going to take it, right? So it removes it. So what's going to happen is now our queue is empty. And then when we pull it, it's going to be null. So that's just one way to check to see in one operation, take the one from the head and also check to see if there's any else in the oven. Element, this works the same as pull, except it doesn't remove the element. It does return an exception if the queue is empty. If it's down right in A, element's going to return the item at the head, and then it's still going to be the same. So if it's empty, you're going to get an exception. So there's a specific exception for trying to check a null queue. So peek returns but does not remove the element at the head. There's also a peek operation on the stack, but for this one, what this does is just returns down. The nice thing is it returns it, but it doesn't remove it, and it would return null. So it's not going to throw an exception like element will. Here's a challenge exercise to make sure you understand what is happening with the queues. But I'm going to move forward and go on to decks. So now we move to deck. And I've heard it called DQs before, but deck is the proper pronunciation. And the reason is because the DE stands for double-ended queue. So what this is this is one in which we can insert and remove from both ends, at the head or the tail of the queue, or the deck. So a stack is also another type of abstract data type in which we can only add or remove from the top of the stack. A stack is a LIFO or FILO, depending on how you look at it. So the first in is going to be the last out. You push them down like a stack of plates and pop them off. Let's take a look at this deck, see how this works. So here we declare a deck called trip route. We have some cities, and we print out some information about when we leave, and then we add them to our deck. Then on the return trip, we would just go in the reverse order. And you can see here this works much like a stack would, because we push them down in Tokyo, Osaka, Nara, and then when we return, we have to go back in the exact opposite. So the deck methods, and again, we can model a stack using decks. So we can do an add first, add last. So this tells us where to position the new element that we want to put on our deck. Remove first and remove last. And then we can pull first, pull last, get first, get last. And the get returns but does not remove the element. So it throws an exception, which we have to be aware of. We can also do a peek, which does this pretty much the same thing. The only difference is it's not going to throw an exception. Here's a challenge activity. Again, I encourage you to look at this because understanding DEX is a powerful tool to model stacks. And stacks are quite common data element or data types that you will have to work with in your Java career.